Something that you need to be mindful of is over-indexing your database. Sometimes in technology, when we learn about a new feature or capability, we have a tendency to apply this capability to every problem we see, whether it's a fit or not. There's an old interview question that I'll sometimes ask along these lines of, if indexing columns improves performance, why don't we index every column in a table? The answer is, because indexes are a separate data structure, they take up additional space on disk, and they create overhead in that the index has to be maintained for any DML operations against the table. What this really goes back to is the idea that indexes are an investment. It is a worthy trade-off to pay some of these costs if an index is used thousands of times a day to speed up our SQL statements. But if an index is seldom used or never used, then we're just paying these costs without the benefit. So let's take a moment and discuss these costs in more detail. The first cost is the easiest to understand, and that is disk space. Again, each index is a separate data structure, and this data structure has to be stored on disk. When Oracle is using the index, it will load the blocks it needs from the index into the buffer cache, and cache those blocks just like it would blocks in a table. Now, Oracle doesn't have to read all of the blocks in the index and cache all of the blocks when it uses the index. It's smart enough to read and cache only the blocks that it needs. The point is, though, whether we're talking about storing the index on disk or having the index in the buffer cache, the index is a separate data structure from your table data, and this separate data structure takes up space. What is the size of this structure? You can find out by running this query. For this query, you'll need permissions to the DBA segments table in the Oracle Data Dictionary, and in this case, we're joining that to the All Indexes view. This version of the query will actually get all of the indexes for a particular table and tell you their size on disk, both in terms of bytes and the number of blocks they take. Why does the amount of space we are devoting to an index matter? A primary reason is the cost of storage. Now, you might be tempted to think that hard drive prices have come way down over the years, and you can go online and purchase a hard drive of several terabytes for less than $100, so space really isn't that expensive. That's true, and that hard drive would work well in a laptop, but it wouldn't work very well in a storage array network. At least at the time of this recording, space in a SAN remains relatively expensive. So yes, storage is cheap, but fast storage is not. So this is a cost that we have to be mindful of. The other major cost we pay with an index is the overhead in maintaining the index when DML operations are executed against the table. For example, if we have a table with 3 indexes, when we do an insert against the table, Oracle also has to update all 3 indexes. This means that we aren't just doing 1 write, but a total of 4 writes. If our table had 6 indexes rather than 3, then we'd be doing a total of 7 writes, 1 for the table and 6 for the indexes. And so you can see the problem. As we get more indexes for any table, doing DML operations against that table increases, because we have to keep all of those indexes in sync. If we are updating a row in our table, then every index that contains a column whose value is being updated will have to be modified. So in this case, we're showing that 2 of the indexes contain a column that is being updated by our update statement. So we'll have a total of 3 write operations, and 2 for the 2 indexes that contain the column being updated. And so you can see the overhead that indexing brings. Because indexes have to be kept in sync with the data in the table, Oracle has to incur this overhead whenever a DML statement is run against the table. Some of this you just have to consider the cost of doing business. It's normal that you're going to have a primary key index on a table and anywhere from 2 to 4 indexes on the table. And so in these cases, there's nothing you can really do to avoid this overhead. But if you had 10, 12, or more indexes on a table, this would really start to impact your DML operations. So you'd want to look at all of these indexes and understand if they were being used or if they were just adding overhead. Let's move into a quick demonstration so we can see what the impact of having too many indexes is when we're trying to conduct DML operations.